Relax. Composable abstractions for end-to-end dynamic machine learning. Dynamic shape computations have become critical in modern machine learning workloads, especially in emerging large language models. The success of these models has driven demand for deploying them to a diverse set of back-end environments. In this paper, we present Relax, a compiler abstraction for optimizing end-to-end dynamic machine learning workloads. Relax introduces first-class symbolic shape annotations to track dynamic shape computations globally across the program. It also introduces a cross-level abstraction that encapsulates computational graphs, loop-level tensor programs, and library calls in a single representation to enable cross-level optimizations. We build an end-to-end compilation framework using the proposed approach to optimize dynamic shape models. Experimental results on large language models show that Relax delivers performance competitive with state-of-the-art hand-optimized systems across platforms and enables deployment of emerging dynamic models to a broader set of environments, including mobile phones, embedded devices, and web browsers. VR-NeRF, High-Fidelity Virtualized Walkable Spaces. We present an end-to-end system for the high-fidelity capture, model reconstruction, and real-time rendering of walkable spaces in virtual reality using neural radiance fields. To this end, we designed and built a custom multi-camera rig to densely capture walkable spaces in high fidelity and with multi-view high dynamic range images in unprecedented quality and density. We extend instant neural graphics primitives with a novel perceptual color space for learning accurate high dynamic range appearance and an efficient MIP mapping mechanism for level of detail rendering with anti-aliasing, while carefully optimizing the trade-off between quality and speed. Our multi-GPU renderer enables high-fidelity volume rendering of our neural radiance field model at the full virtual reality resolution of dual 2K by 2K at 36 Hz on our custom demo machine. We demonstrate the quality of our results on our challenging high-fidelity datasets and compare our method and datasets to existing baselines. We release our dataset on our project's website. S-LoRA, serving thousands of concurrent LoRa adapters. The pre-train then fine-tune paradigm is commonly adopted in the deployment of large language models. Low-rank adaptation, LoRa, a parameter-efficient fine-tuning method, is often employed to adapt a base model to a multitude of tasks, resulting in a substantial collection of LoRa adapters derived from one base model. We observe that this paradigm presents significant opportunities for batched inference during serving. To capitalize on these opportunities, we present S-LoRA, a system designed for the scalable serving of many LoRa adapters. S-LoRA stores all adapters in the main memory and fetches the adapters used by the currently running queries to the GPU memory. To efficiently use the GPU memory and reduce fragmentation, S-LoRA proposes unified paging. Unified paging uses a unified memory pool to manage dynamic adapter weights with different ranks and KV cache tensors with varying sequence lengths. Additionally, S-LoRA employs a novel tensor parallelism strategy and highly optimized custom CUDA kernels for heterogeneous batching of LoRa computation. Collectively, these features enable S-LoRA to serve thousands of LoRa adapters on a single GPU or across multiple GPUs with a small overhead. Compared to state-of-the-art libraries such as Hugging Face PEFT and VLLM with naive support of LoRa serving, S-LoRA can improve the throughput by up to 4 times and increase the number of served adapters by several orders of magnitude. As a result, S-LoRA enables scalable serving of many task-specific fine-tuned models and offers the potential for large-scale customized fine-tuning services. GLaMM, Pixel Grounding Large Multimodal Model. Large multimodal models, LLMs, extend large language models to the vision domain. Initial efforts towards LLMs used holistic images and text prompts to generate ungrounded textual responses. Very recently, region-level LLMs have been used to generate visually grounded responses. However, they are limited to only referring to a single object category at a time, require users to specify the regions in inputs, or cannot offer dense pixel-wise object grounding. In this work, we present grounding LLM GLaMM, the first model that can generate natural language responses seamlessly intertwined with corresponding object segmentation masks. GLaMM not only grounds objects appearing in the conversations, but is flexible enough to accept both textual and optional visual prompts, region of interest, as input. This empowers users to interact with the model at various levels of granularity, both in textual and visual domains. Due to the lack of standard benchmarks for the novel setting of generating visually grounded detailed conversations, we introduce a comprehensive evaluation protocol with our curated grounded conversations. Our proposed grounded conversation generation (GCG) task requires densely grounded concepts in natural scenes at a large scale. To this end, we propose a densely annotated grounding anything dataset, GRAND-E, using our proposed automated annotation pipeline that encompasses 75M unique concepts, grounded in a total of 810M regions available with segmentation masks. Besides GCG, GLaMM also performs effectively on several downstream tasks, for example, referring expression segmentation, image and region-level captioning, and vision language conversations. Project's website. CogVLM, Visual Expert for Pre-trained Language Models. We introduce CogVLM, a powerful open-source visual language foundation model. Different from the popular shallow alignment method which maps image features into the input space of language model, CogVLM bridges the gap between the frozen pre-trained language model and image encoder by a trainable visual expert module in the attention and FFN layers. As a result, CogVLM enables deep fusion of vision language features without sacrificing any performance on NLP tasks. CogVLM 17B achieves state-of-the-art performance on 10 classic cross-modal benchmarks, including no caps, Flickr 30K captioning, RefCoco, RefCoco Plus, RefCocog, Visual 7W, GQA, Science QA, VisWiz VQA, and TDIUC, and ranks the second on VQAV2, OKVQA, Text VQA, Coco captioning, etc., surpassing or matching PaliX 55B. Codes and checkpoints are available at the project's website. MFTCoder, boosting code LLMs with multitask fine-tuning. Code LLMs have emerged as a specialized research field, with remarkable studies dedicated to enhancing models' coding capabilities through fine-tuning on pre-trained models. Previous fine-tuning approaches were typically tailored to specific downstream tasks or scenarios, which meant separate fine-tuning for each task, requiring extensive training resources and posing challenges in terms of deployment and maintenance. Furthermore, these approaches failed to leverage the inherent interconnectedness among different code-related tasks. To overcome these limitations, we present a multitask fine-tuning framework, MFTCoder, that enables simultaneous and parallel fine-tuning on multiple tasks. By incorporating various loss functions, we effectively address common challenges in multitask learning, such as data imbalance, varying difficulty levels, and inconsistent convergence speeds. Extensive experiments have conclusively demonstrated that our multitask fine-tuning approach outperforms both individual fine-tuning on single tasks and fine-tuning on a mixed ensemble of tasks. Moreover, MFTCoder offers efficient training capabilities, including efficient data tokenization modes and PEFT fine-tuning, resulting in significantly improved speed compared to traditional fine-tuning methods. MFTCoder seamlessly integrates with several mainstream open-source LLMs, such as CoDeLlama and Qwen. Leveraging the CoDeLlama Foundation, our MFTCoder fine-tuned model, CodeFuse CoDeLlama 34B, achieves an impressive pass at one score of 74.4% on the Humane Evil benchmark, surpassing GPT-4 performance 67% zero-shot. MFTCoder is open-sourced at the project's website. Levels of AGI, operationalizing progress on the path to AGI. We propose a framework for classifying the capabilities and behavior of artificial general intelligence, AGI, models and their precursors. This framework introduces levels of AGI performance, generality, and autonomy. It is our hope that this framework will be useful in an analogous way to the levels of autonomous driving, by providing a common language to compare models, assess risks, and measure progress along the path to AGI. To develop our framework, we analyze existing definitions of AGI and distill 6 principles that a useful ontology for AGI should satisfy. These principles include focusing on capabilities rather than mechanisms, separately evaluating generality and performance, and defining stages along the path toward AGI rather than focusing on the endpoint. With these principles in mind, we propose levels of AGI based on depth performance and breadth generality of capabilities, and reflect on how current systems fit into this ontology. We discuss the challenging requirements for future benchmarks that quantify the behavior and capabilities of AGI models against these levels. Finally, we discuss how these levels of AGI interact with deployment considerations such as autonomy and risk, and emphasize the importance of carefully selecting human-AI interaction paradigms for responsible and safe deployment of highly capable AI systems. ZIA 2. Data-centric learning is all LLMs need. Various large language models, LLMs, have been proposed in recent years, including closed and open source ones, continually setting new records on multiple benchmarks. However, the development of LLMs still faces several issues, such as high cost of training models from scratch and continual pre-training leading to catastrophic forgetting, etc. Although many such issues are addressed along the line of research on LLMs, an important yet practical limitation is that many studies overly pursue enlarging model sizes without comprehensively analyzing and optimizing the use of pre-training data in their learning process, as well as appropriate organization and leveraging of such data in training LLMs under cost-effective settings. In this work, we propose ZIA 2, a model with 13 billion parameters adopting LLaMA 2 as the foundation model, and further pre-trained on 700 billion tokens, where we focus on pre-training techniques and use data-centric optimization to enhance the learning process of ZIA 2 on different stages. Experiments show that ZIA 2 significantly outperforms other models in multiple benchmarks, especially with promising results compared to representative open-source ones. ZIA 2 Base is released at the project's website. Tell your model where to attend. Post-hoc attention steering for LLMs. In human-written articles, we often leverage the subtleties of text styles, such as bold and italics, to guide the attention of readers. These textual emphases are vital for the readers to grasp the conveyed information. When interacting with large language models, LLMs, we have a similar need, steering the model to pay closer attention to user-specified information, for example, an instruction. Existing methods, however, are constrained to process plain text and do not support such a mechanism. This motivates us to introduce PASTA, Post-hoc Attention Steering Approach, a method that allows LLMs to read text with user-specified emphasis marks. To this end, PASTA identifies a small subset of attention heads and applies precise attention reweighting on them, directing the model attention to user-specified parts. Like prompting, PASTA is applied at inference time and does not require changing any model parameters. Experiments demonstrate that PASTA can substantially enhance an LLM's ability to follow user instructions or integrate new knowledge from user inputs, leading to a significant performance improvement on a variety of tasks. For example, an average accuracy improvement of 22% for LLaMA 7B. Our code is publicly available at project's website. LDM3, DVR Latent Diffusion Model for 3D VR. Latent diffusion models have proven to be state-of-the-art in the creation and manipulation of visual outputs. However, as far as we know, the generation of depth maps jointly with RGB is still limited. We introduce LDM3DVR, a suite of diffusion models targeting virtual reality development that includes LDM3D-Pano and LDM3D-SR. These models enable the generation of panoramic RGBD based on textual prompts and the upscaling of low-resolution inputs to high-resolution RGBD, respectively. Our models are fine-tuned from existing pre-trained models on datasets containing panoramic/high-resolution RGB images, depth maps, and captions. Both models are evaluated in comparison to existing related methods. Ultra-long sequence distributed transformer. Transformer models trained on long sequences often achieve higher accuracy than short sequences. Unfortunately, conventional transformers struggle with long sequence training due to the overwhelming computation and memory requirements. Existing methods for long sequence training offer limited speed-up and memory reduction and may compromise accuracy. This paper presents a novel and efficient distributed training method, the long-short sequence transformer, LSS transformer, for training transformer with long sequences. It distributes a long sequence into segments among GPUs, with each GPU computing a partial self-attention for its segment. Then it uses a fused communication and a novel double gradient averaging technique to avoid the need to aggregate partial self-attention and minimize communication overhead. We evaluated the performance between LSS transformer and the state-of-the-art NVIDIA sequence parallelism on a Wikipedia NWIC8 dataset. Results show that our proposed method lead to 5.6x faster and 10.2x more memory-efficient implementation compared to state-of-the-art sequence parallelism on 144 NVIDIA FOV 100 GPUs. Moreover, our algorithm scales to an extreme sequence length of 50,112 at 3,456 GPUs, achieving 161% superlinear parallel efficiency and a throughput of 32 petaflops. Consistent 4D, consistent 360 degrees, dynamic object generation from monocular video. In this paper, we present consistent 4D, a novel approach for generating four-dimensional dynamic objects from uncalibrated monocular videos. Uniquely, we cast the 360-degree dynamic object reconstruction as a four-dimensional generation problem, eliminating the need for tedious multi-view data collection and camera calibration. This is achieved by leveraging the object-level three-dimensional aware image diffusion model as the primary supervision signal for training dynamic neural radiance fields, DynRF. Specifically, we propose a cascade DynRF to facilitate stable convergence and temporal continuity under the supervision signal, which is discrete along the time axis. To achieve spatial and temporal consistency, we further introduce an interpolation-driven consistency loss. It is optimized by minimizing the discrepancy between rendered frames from DynRF and interpolated frames from a pre-trained video interpolation model. Extensive experiments show that our consistent 4D can perform competitively to prior art alternatives, opening up new possibilities for four-dimensional dynamic object generation from monocular videos, whilst also demonstrating advantage for conventional text-to-three-dimensional generation tasks. Our project page is project's website. CogVLM, composing visual entities and relationships in large language models via communicative decoding. A remarkable ability of human beings resides in compositional reasoning, that is, the capacity to make infinite use of finite means. However, current large vision language foundation models, VLMs, fall short of such compositional abilities due to their bag-of-words behaviors and inability to construct words that correctly represent visual entities and the relations among the entities. To this end, we propose CoVLM, which can guide the LLM to explicitly compose visual entities and relationships among the text, and dynamically communicate with the vision encoder and detection network to achieve vision-language communicative decoding. Specifically, we first devise a set of novel communication tokens for the LLM for dynamic communication between the visual detection system and the language system. A communication token is generated by the LLM following a visual entity or a relation, to inform the detection network to propose regions that are relevant to the sentence generated so far. The proposed regions of interests, ROIs, are then fed back into the LLM for better language generation contingent on the relevant regions. The LLM is thus able to compose the visual entities and relationships through the communication tokens. The vision-to-language and language-to-vision communication are iteratively performed until the entire sentence is generated. Our framework seamlessly bridges the gap between visual perception and LLMs and outperforms previous VLMs by a large margin on compositional reasoning benchmarks. For example, approximately 20% in High-Fidelity, approximately 14% in Cola Top 1 accuracy, and approximately 3% on ARO Top 1 accuracy. We also achieve state-of-the-art performances on traditional vision language tasks, such as referring expression comprehension and visual question answering. Co-training and co-distillation for quality improvement and compression of language models. Knowledge distillation (KD) compresses computationally expensive pre-trained language models (PLMs) by transferring their knowledge to smaller models, allowing their use in resource-constrained or real-time settings. However, most smaller models fail to surpass the performance of the original larger model, resulting in sacrificing performance to improve inference speed. To address this issue, we propose co-training and co-distillation, CTCD, a novel framework that improves performance and inference speed together by co-training two models while mutually distilling knowledge. The CTCD framework successfully achieves this based on two significant findings. 1. Distilling knowledge from the smaller model to the larger model during co-training improves the performance of the larger model. 2. The enhanced performance of the larger model further boosts the performance of the smaller model. The CTCD framework shows promise as it can be combined with existing techniques like architecture design or data augmentation, replacing one-way KD methods to achieve further performance improvement. Extensive ablation studies demonstrate the effectiveness of CTCD, and the small model distilled by CTCD outperforms the original larger model by a significant margin of 1.66 on the GLue benchmark. Tailoring self-rationalizers with multi-reward distillation. Large language models, LLMs, are capable of generating free text rationales to aid question answering. However, prior work suggests that useful self-rationalization is emergent only at significant scales, for example 175B parameter GPT-3, and focuses largely on downstream performance, ignoring the semantics of the rationales themselves, for example. Are they faithful, true, and helpful for humans? In this work, we enable small-scale LLMs, approximately 200 times smaller than GPT-3, to generate rationales that not only improve downstream task performance, but are also more plausible, consistent, and diverse, assessed both by automatic and human evaluation. Our method, Mario, multi-reward rationalization, is a multi-reward conditioned self-rationalization algorithm that optimizes multiple distinct properties like plausibility, diversity, and consistency. Results on 5 difficult question-answering datasets: Strategy QA, Quarel, OpenBook QA, NumSense, and QASC show that not only does Mario improve task accuracy, but it also improves the self-rationalization quality of small LLMs across the aforementioned axes, better than a supervised fine-tuning SFT baseline. Extensive human evaluations confirm that Mario rationales are preferred versus SFT rationales, as well as qualitative improvements in plausibility and consistency. Attention or convolution. Transformer encoders in audio language models for inference efficiency. In this paper, we show that a simple self-supervised pre-trained audio model can achieve comparable inference efficiency to more complicated pre-trained models with speech transformer encoders. These speech transformers rely on mixing convolutional modules with self-attention modules. They achieve state-of-the-art performance on automatic speech recognition, ASR, with top efficiency. We first show that employing these speech transformers as an encoder significantly improves the efficiency of pre-trained audio models as well. However, our study shows that we can achieve comparable efficiency with advanced self-attention solely. We demonstrate that this simpler approach is particularly beneficial with a low bit weight quantization technique of a neural network to improve efficiency. We hypothesize that it prevents propagating the errors between different quantized modules compared to recent speech transformers, mixing quantized convolution and the quantized self-attention modules.